So today's lecture has three parts. You had chapters 15, 16, and 17. So we'll talk about scope a little more than we have before. We'll talk about types a little more than we have before. And then we're going to talk about exceptions and kind of how you can control handling certain errors in your code, which is a good skill to know how to do. All right, got some announcements, actually just one announcement, and then lecture, and then your studio tonight is a non-coding studio. So you guys will have more of a discussion led by your TA. And then when you come back, I'm actually there's not really a review to do, but I thought what I could do is offer some time for you guys to just ask questions. If there are still concepts, we've covered a lot of stuff in the last few weeks, right? So if there are still things that you are struggling to put, connect all the dots, things that you'd like to know to, just make it a little stronger for yourself, I can live code some examples, but I'll take questions. And studio may not take that long tonight. Lecture may not take that long tonight. We'll see. So what I probably will do is just stay in this room and keep it open so that when you guys get done with your studio, if you're done way early, like way earlier than 8 o'clock, you can just come over and jump in and I'll just take questions as they come. Speaking of questions, the announcement tonight, I want to try something new based on some feedback I got. I know it's always a struggle, especially when we have a lot to cover in lecture, to get to everybody's questions and just kind of the flow of how that works. So what I would like to do is, if you are not already doing it, use the reactions button in Zoom to actually raise your hand. And of course, obviously, there's lots of other fun things that you can do, different emoji and whatnot. But raise your hand and I will call on people to answer questions. And yes, I see some of you trying it out. Perfect. So part of the idea behind this is to give other people a chance to respond when I'm kind of asking questions and you guys are popping out answers. And then also just to help with the flow of because I know you guys don't want to interrupt me, but you also have burning questions. But then I would also remind you to continue to use the lecture questions channel, because the TAs are monitoring that, your peers might catch things, and they will be able to get to the things that I can't get to. So let's see how this goes. We'll do the raise hands thing, and that's easier for me to keep track of than anything, the way that Zoom kind of works when you're in presentation mode. Okay, so with that, let's talk about scope. So scope is the idea of variable access. First, I'm just going to kind of review the idea of what a code block is, so everybody's clear on that. And then we'll talk about local or block scope versus global scope. We'll talk about variable shadowing and variable hoisting. So code blocks are basically any section of code that is executed within the body of like a function or some kind of mechanism like a loop or conditional. That's a code block. So essentially you can kind of think of it, generally speaking, it's going to be everything between the curly braces, right, that are part of one of those mechanisms. So we have an example here of some code, and I've started out just by declaring a variable out in the code at the top level. Let hello equal hello, and then I've logged it with console.log. And this would be not a block of code. It's just a couple lines of code. It's not a block. So then we have this string alpha with the alphabet in uppercase letters. It's going to kind of help us with this function. So we have a function, and this entire function is its own block, right? Everything between the curly braces of the function, that's the function block. So that's kind of the next level down from the top level. And then nested inside the function, you've got this for block that has a couple lines of code, right? That's the next level down. And then we can go even further and have this, if block that has one line of code. So you have 4 different levels of code blocks here. Well, three levels of code blocks, and then you have the top level that is not a block. It's just, all the code. And we're going to get into this in a minute and look at it as an example. But I just wanted to kind of make sure everybody was clear. When I talk about code blocks, this is what I mean. Okay. So with that, we can talk about scope, local and block scope versus global scope. So when you use let or const to declare a variable inside a code block, that's a local scope. It's local to that block or anything that's nested inside it. And you can also think of parameters of a function being locally scoped, right? They're only accessible from inside that function. Meanwhile, global scope is where you are just using let or const to declare a variable at the top level. It has to be outside the code blocks, and then it's accessible from anywhere. So if you ever have anything that needs to be accessible from anywhere, you may have to make sure to declare it at the top level. I know that you guys already know some of this because we kind of brought it up early. I've talked about some of this before, but I want to make sure to cover it in some detail just in case there's any lingering, questions about how all this works. So I've got this example here of, declaring the constant pi at the top level. So then I've got a function get circumference, and you can see that pi is used in there. And there's also a new variable that's local to the function diameter. And then of course, there's the parameter radius that's also local to the function. And when I return, pi times diameter, everything should work. So if you look further down there, I've got the console.log, of pi that, is accessible. But if I try to console log diameter, it throws me a reference error because it's not accessible from outside the function. In the next example, you've got the area of a circle, and you again have a parameter radius completely separate from the other one because they're both, only local to their functions. And in this case, I declare an abbreviated version of pi with a different variable name, and I use that instead. So there again, if I try to console log lowercase pi from outside, I'm going to get a reference error because it's not accessible. It was declared inside that function. Does anybody have any questions about that? All right, let's go over to, let's see, let me make sure. Yeah, let's come over to the Repl here. And I want to kind of demonstrate some of this for you with both of these examples. So let's go back to the alpha example, this spell and shout function, which is kind of a silly example, but it proves the point. And hello is declared globally, as is alpha. And greeting is a parameter, so it's local to the function. Shout is declared at the function block level, so it should be accessible anywhere inside here. And then inside the for block, we have this new variable loud letter, and that's only accessible inside the for block, but not outside it up here or after that. And then of course, inside the if block, we're able to console log this because it was declared outside it, and it's perfectly accessible there. So I can run this, and I have to actually I'll uncomment both of those. Okay, so we can see up here, we've console logged hello, no problem. It gives us hello. And then we, run spell and shout. It goes through one at a time and takes shout, and it only console logs it if it's actually included in alpha. So it skips the exclamation point, right? So what if if I try right now to log any of these, I get reference error on greeting. If I comment that out, then we try shout. Oh, shout is not defined. So I say, okay, I'm not worried about that anymore. And now it'll actually be able to get down to this line, and we run it, and it says loud letter is not defined. Okay, so we have confirmed that those are all reference areas because none of them are accessible out here outside the function. So what if I was to go in and actually try to, I'm actually going to, well, it's okay, I'll type it. What if I try to, console log shout from inside the for loop? oh, I have to actually run the function in order for this to execute, don't I? All right. Yeah. That works because shout was declared outside the for loop, so it's also accessible inside the for loop. But if I were to try to log, let's see. And if I were to try to log loud letter, it should also work because we're on the same level here. It was declared inside the for loop, so that should show up as well. Okay. And if I were to move these up, sorry, not up, out. If I were to move the loud letter out to here, I'm going to try to run it, and it's going to be a reference error again, because now I'm outside the for block and loud letter doesn't exist out here. So these are just a few examples of, so if you ever have a problem like that, it's probably just because you got to check your scope and make sure that the variable has been declared in a place where your code can reach it. It can actually get to the value. Okay, so, same thing here. I can just demonstrate these. Yeah, so it's, it runs everything. Let's get this out of there. And, it runs pi fine, but then it gets to diameter and it can't access it because it's inside here. And I could try to do radius as well, which were, of course, were the, that was the parameter of these, and that's not accessible from outside, and neither is lowercase pi. So the only one that's accessible outside the functions is the one that was declared outside the functions. Okay, now that's not to say that you couldn't have something that was declared outside, but then you change the value inside. Like if you change the value inside, then you go and you access it and it's got the new value. And you guys know this because you've experienced it multiple times now. This is not going to be new to you. Okay, so let's talk about variable shadowing. I have talked about this before. I wanted to bring it up earlier in the course because it was kind of coming up with some other things you guys were doing. But since it was covered in chapter 15, I'm going to go ahead and talk about it again. So I called this AKA how to create chaotic code because that's pretty much what happens. If you use the same variable name in two different scopes, it's called shadowing. It is confusing for others. It is confusing for you. Don't do it. That's all I really have to say about this. So I've got this example where, and I'm just going to flip over to the code. I've got word that's globally declared as trick, but I also have created this function that uses the same variable name as the parameter. And if I console log that, JavaScript is going to choose the parameter over the global one. Similarly, if I have this function print and I declare a word inside this function, and then I go to log that out, it's going to choose the local one again over the global one. And we can demonstrate that by logging these out. Yeah, trick or treat. So I guess I didn't finish my comments here. Here we go. So that's pretty much all there is to say about that. Just avoid it. Try to use unique names for everything if you have things that might end up in the same scope. Okay. Variable hoisting. It is technically possible to initialize or reference a variable before you declare it, but only if you use the keyword var, which is like old school let, but it functions a little differently. And you guys have been taught to use letter const, and that's because that's what's modern, done in modern practice. So continue to use letter const, declare your variables ahead of using them, and you will not have any problems. But just so you know, this is how this works in case you come across older code that's using var and you see this and you're confused. This is how it works. I can declare var with holiday after setting the value, and I can log it out and it's fine. It got the value even though I didn't declare it before I used it. Or before I set the value, I should say. But I can try, with let, I can set costume 1, but it'll only let me access it if I do it after I declare it. If I try to do it with, that's in the case of Gamora. In the case of Star-Lord, if I try to do that, I can say, costume 2 is equal to Star-Lord. Try to give it the value right there on that line before it even gets to the next line. It's going to stop and say there's a reference error, because I used let and not var. And that's because this idea of hoisting is basically that when JavaScript is compiling the code, if it sees var, it pulls it up, it hoists it up as if you had declared it at the top of your code, and then it actually can run it from there. But if you have used let, it keeps it where it is. And so then when the code runs, it hasn't found it yet. That's why it's called hoisting. And I can demonstrate this as well. So here again, let me uncomment these and I'll comment these back out. We'll run it. Yeah, so we get I forgot to uncomment this. Haha, that helps. Yeah, so if in this case, because I had not actually tried to give it a value, it was saying it was undefined because I declared it, but I didn't initialize it, right? But if I actually try to do this, this is where it's going to throw the error. Yeah, so now we have a reference error because it says I can't access costume 2. You tried to use it before you initialized it with that. But Halloween, it actually had hoisted it, and when it compiled the code, it put it up at the top. Mike?
So with that variable holiday, VAR holiday, like you could have put that below everything and it still would have the same effect?
Yep.
Okay.
Yep, because that's, that process of compiling is where JavaScript goes through all the code and it writes a whole new file, and it puts things in the order it wants to put them in and writes it the way it needs to write it to execute it. And so in that process, anything that's been declared with var gets moved to the top, and then when it executes, it finds it first. But let doesn't do that. But as I said, no one these days really uses var, and it's just good practice to declare ahead of time so that your code is clear. So I would avoid it, honestly. Okay. All right. So that's pretty much it on scope. If you have any further questions about that, I will take them now. Does anybody have more questions about scope?
I did have a thought earlier. So if you've got multiple files where you're pulling a function from a different file, and say that function has variables within that file, if you call that function in a different file, will it pull the variables from the function file?
Yeah, so what you're talking about is modules, right? If you were to if you run the function and the function is in the other file and the variables it needs are in that same file in scope for it, then no problem. Modules really wouldn't work if that didn't work, right? But if you needed to access the value of the variable all by itself, if you haven't exported it, then you can't access it. But
Gotcha.
Yeah, but the function can if it needs to, yeah. Because in that file, that would be global for that function. Yep.
Thank you.
Sure. Okay, let's talk about more about types. You guys are pretty familiar with most of the types now that are used most of the time. But we'll talk about primitives versus objects, and we'll talk about null and undefined. So primitives, string, number, Boolean, those you're super familiar with. Null is this one that I sort of introduced on Thursday, and we'll talk about a little more in a second. And then undefined. And just to be clear, null is a value, and undefined is both a value and a type. it gets a little tricky when you ask, actually, I'll demonstrate this in a second, but it gets a little tricky when you ask JavaScript to tell you the type of null because it actually tells you it's an object, but it's not. The whole point of null is that it doesn't have any sort of value yet. But object types, these are data structures. These are structures that can hold other types of data, including its own type, right? So arrays can hold arrays, which can hold strings and, you know, numbers and Booleans and null. And objects can do the same. You can have properties that hold, you know, primitive values, or they can hold more objects. So that's where it actually starts to, you start talking about structures, because there are ways to put data inside data. But with primitives, the idea is that you can't do that. It just has a value, a single value. So in this examples, I've got, you know, a string, a number, a Boolean, and then I've got, you know, this empty value, and this not initialized variable that is not initialized. I was real creative with that variable name, and a little on the nose, right? But its value is undefined because it doesn't have a value yet. And then I've got the array. The array has one of each. It's got a Boolean, it's got a number, it's got a string, and then it's got an array, and then it's got an object. And then this object has, you know, a number of different types of values, right? So with null and undefined, the real difference here is that null means empty. And you can actually, you know, set a bunch of properties in an object, which is typically, I mean, you can see null anywhere, but you'll especially see it a lot in data that, like, especially data you're pulling from somewhere else, like someone's got some data in a database and you go and you know, pull it, you fetch it, and it comes to you, and maybe some of the properties are there, but they don't have values. In that case, the value is null. It just means the property exists, but there's no value attached to it. So in this example, I've got the sale price being null. And that kind of makes sense for this example because if the house is either not for sale or it's on sale, or, you know, for sale, but it hasn't sold yet, then there's not going to be a sale price at this particular given time. And so that would just be null. So let me actually do my bullet points here. Yeah. So you use null when you want it to be defined, but you don't want a value. And yeah, often used for values or properties. Undefined means non-existent. It just does not exist. JavaScript can't find it. So in this example, you know, I can access the year built property. I can access the for sale property, but I can't access address because it doesn't exist. So it's just going to come back as undefined. And I have this example as well. So let me get, I'm just going to comment out all of that. And here we've got, yes. So these, this is from the previous slide. These, if I actually run these types, this is where I was talking about where if you actually try to type empty value here, it's going to tell you it's an object, but it is absolutely 100% a primitive. JavaScript in their own documentation says this. So I'm not really sure why it comes back and says it's a type of object, because it's not. But then you come down here and you do the type of array and object, and those both come back as object because an array is of type object, even though it's not what we would call an object. Okay. So that's those. Comment those out. Okay, here's the house example. So we can kind of see this. Year built should come out in 1929. In this case, I have for sale is true, and you know that comes out true. But then I'm sorry, I forgot to do the other one. Sale price. There we go. Yeah, so sale price comes out as null. So you can see the property exists. There's just no value for it yet. But address doesn't exist at all, and that's why it's undefined. So that's kind of the essential difference between null and undefined. And you will come up against both at different points when you're working with data. Okay. Are there any questions about these types before we move on?
I do have one small question about null.
Sure.
I've heard before that, like, this might be other languages that I'm just compounding in my head, but that sometimes things that are null can cause the program to halt in certain situations.
That's true, and that's why we have error handling. Because if your program is expecting a real value in order to be able to calculate something or to do something with it otherwise, and it's like it's null, and it can't do it, then it's just going to break in some circumstances. And so that is where we actually are intentional about handling exceptions, which is what we're about to talk about.
Okay, thank you.
Yeah.
I have a question on this one.
Yeah.
So whenever you went over to the Repl, the sale price on this one on the screen says null, but then it says, okay, sale price on this one says null on line 117 and on 122. So then that means the third one comes out null. Right, I was just trying to understand how the previous page worked. I feel like maybe I'm confused on it.
That's okay. So yeah, you can
Go
see
to the previous page. I think there's maybe something there that's confusing me. This makes sense. Okay. I think it was the previous page that doesn't make sense to me.
when you say the previous page, are you talking about the slide?
Yeah.
Yeah, that's because I have a typo. Yeah.
Okay, sorry. Yeah. Okay.
I accidentally
Maybe I
said
missed it.
for sale and I meant to say sale price. Yeah, I'll fix it later.
I think sorry. Yeah.
Yeah, I didn't realize it until I got over here to the code and I was like, wait a second, that's not what I meant to do. Yeah, so we could like just take that off of there and yeah, then you'll see the 1929 null and undefined. That's what I meant to do. Okay, yeah, sorry, didn't mean to confuse you guys. I mean, I never do. I never want to confuse you guys. Just inadvertently do it sometimes. Okay, let's talk about error objects. So exceptions are errors, runtime errors, and we are going to talk about how to handle them. So we'll revisit the common error types, talk about the error object, and then how to raise exceptions, which another way to say that is to throw an error. And then we'll talk about the try, catch, and finally blocks that you can use in your code to handle situations when you think you might end up with an error. So common error types. We've talked about errors during execution, kind of this, the second phase after your code is compiled. You can have, errors during the execution of the code. Everything's going swimmingly until it's not, and suddenly you have an exception. So, yeah, reference error and type errors are probably the two that you come across the most often as runtime errors. And remember that you don't have any messages for logic errors. Your logic errors are just, the sequencing of your code and telling it how to execute it. So those are things where you have to kind of debug and you have to figure it out yourself. But we're going to focus on the types of errors that you can actually get messages on, or you can create messages for. But, I've got this example here of, I've declared this variable 3 and I try to make it uppercase, but it turns out that it's actually a number and not a string. And so you get a type error because it's like, you can't call to uppercase on 3, it's a number. So the error object, built-in error object, at minimum is going to have a name and a message. It also usually has a stack property, but I'll show you that in a second. When an error is thrown by JavaScript, it prints this entire stack trace, which are the details about where the error occurred and what led up to it. So you can kind of see in this example that I just had, we know that this throws a type error, but what you actually see in the console is this whole thing. It gives you the name, a colon and a space, and then it gives you the message. And then after that, it tells you kind of where it happened. It gives you a line number. It even gives you a column number. That's what the 20 is on that 133:20. So you can say this is exactly where this happened. And you can't really see the error object, but you can visualize it. And it kind of basically, the basic two properties that you interact with the most are name and message. And this is pretty much how you can visualize it, right? The name is type error, the message is this message. Okay. So I'm going to demonstrate that real fast here. Let's get rid of these. And we will just demonstrate this type error here. Yeah. So this is exactly what I had, right? And you guys have seen this once or twice, probably, or a whole lot more than that, because we have errors constantly as we code. And this is how we learn and how we get our code working properly. Okay. So if we go on to the next slide, I want to talk about oh, there we go. All right. Custom errors. You can actually create your own error types. You can use this keyword new to create an instance of the error class. Now, those are words that might be new to you, and we're not talking about classes until Thursday. But essentially the idea is a class defines what an object's properties and methods are. And then you can have multiple instances of that class, and each of those are unique objects. So every time you have one of these error objects, it's just an instance of the error class, and it has the same structure. So you can create one all on your own by using this keyword new. And then you can give it your own helpful custom message. And you can even selectively print parts of the object, or you can print the entire stack trace. So in this example, we've got, this keyword new here. I've decided to have this variable E, which is not an uncommon way to very briefly refer to an error. You'll see it a lot. And I use the keyword new so that I can create the new instance of error. And then I give it the specific error type. It doesn't have to be generic error. It could have, I could create one that's, type error. I could create one that's range error, or, reference error, right? And then I give it the message, and that's the first argument that you give it. You can actually give it multiple arguments, but we're going to stay simple for now. So we'll focus on the message. So that's the third little part there. So I can log out the name, and that's the error type. I can log out the message, which is whatever I gave it, that string. If I log just E, and I'm expecting to see the object, I'm not actually going to see the object. I'm going to see the stack trace. If I log E.stack, which is another property that is usually there, it gives me the stack trace. It just gives it to me as like a plain string instead of providing it in special formatting. I'll show this to you in just a second. And then this last part, if you actually take the E object and you stringify it, like you force JavaScript to turn it into a string, either by using a template literal like this or by concatenating it with something, then it has this built-in method it uses called toString. And it's actually got its own little thing. And that's why you see it with like the name and a colon and the message after it. It's because that's kind of built in behind the scenes. And so let me demonstrate this for you. Okay, so let's do these first. Actually, I'm going to do just those first three. Okay, so the error type, we know that we created this as a generic error. So I see error, and then I gave it this message, a custom message. So this line here is showing me a custom message. And then when I console log the entire E object, just like that, I get the stack trace, which is everything from here to here. And you'll notice how, some of it is kind of formatted in this gray, just like it would do if it was, printing it, except it's not in red. And then if I try to actually do E.stack, I kind of get the same thing, but it's all just a regular string. That's not really important. I just wanted to show you there is a slight difference, but otherwise it's pretty much the same. Now, this is the one where it's interesting because I've actually put E in a template literal so that it'll force it to be a string and it'll use that E.toString behind the scenes. And that's where we get that first part of the stack, which is just the name, colon, space, and message. Does anybody have questions about that? Mina.
Can you walk through the recent example once again, Kerry?
Okay. Is there a particular part?
From the error e.name.
Okay, so because we know that this is an object, right? It has these properties, name and message. I can access those individually and just make use of them however I want to. So I've just shown you I can log out just the name, or I can log out just the message. Or if I log E or E.stack, in both cases, I get the entire stack trace. And then down here where I have forced it to turn it into a string, that E object gets turned into just the name and message. Josh?
So is there really a reason to do E.stack instead of just E then?
Probably not. I just figured you guys might come across it at some point. I honestly, there might be, I'm not a back-end engineer. So if there was a back-end engineer, they might know. Yeah, typically you're probably going to find yourself most of the time doing one of these three. Just the name, the message, or the entire thing. Mina, did you have another question?
No,
Raise your-
it's Kerry.
Okay, I just saw your hand stop. Okay. All right, so let's dig into this a little bit more, because you can actually make use of this by raising exceptions on purpose. You can throw errors. So if you choose to raise an exception, you can use this keyword throw, and then you can use the keyword new, like we talked about on the last slide, to create an instance of the error class with that. And of course, give it a helpful custom message. So in this example, I have the gravitational acceleration constant, 32.17 feet per second, feet per second squared, feet per second, however you want to say that. And I've got this function that is going to calculate how long it takes for something to get to the ground based on the height that it starts at. So this is like a free fall formula, essentially. So I give it the height in feet. And I return down there at the bottom, math dot square root, and then so I do the math. This is the formula, and that gives us the return value is going to be the number of seconds that it takes. But I know that sometimes, like maybe there's some reason why someone goes to use this formula, or maybe I have it set up where there's like some user input or something, and I get, text that can't be converted into a number. And I don't want it to just return, NaN, not a number. I want to actually throw an error and say specifically, hey, here's what you did. And this is the kind of thing that is really not so much for the benefit of like your end user as it is for other developers who might be, using some utility function you've written that a bunch of people are sharing and using in different parts of the code. And honestly, most of the time when I'm throwing errors, in reality, it has to do with like, receiving data from a database and like, making sure that I got what I was expecting to get and that sort of thing. But this is a good simple example to just kind of show you how to do it. So in this case, I know that it's possible that the value may not be able to be converted to a number. In that case, I want to throw an error and I want to have a meaningful message so that the person who's looking at the console says, oh, that's what I did wrong. I didn't use this the way it was intended to be used. And I want to make this point now while I'm thinking about it. This is also a form of documentation. when you have these kinds of errors and you very intentionally and thoughtfully put errors in the code that will indicate that something isn't being used the way it was meant to be used, it's very, very helpful for your fellow developers. So this is a good example of that. Even if it's kind of a silly function. It shows you how to do it. That's my main thing here. So, I've got this kind of conditional thing here where it's going to throw it if it can't convert it to a number. So I, console log, and I call the function time to ground, and I pass it the string 30 with letters, which it cannot convert, right? So then you get a type error, and it actually, it throws the error, and it'll give you type error, colon space, height must be a number. And we can demonstrate this. Let me get those out of there. All right, so I'm gonna run all three of these. We've got, we expect 30 to work because it is a number. And we even expect 30 in quotes to work because I've actually taken the care to convert height to a number here on my return statement. But watch what happens if I don't handle it. If I don't handle it, it just comes back not a number. That's not very helpful. It might take a second to realize, like, what did I do? And then because you're not necessarily seeing the value of what was put in, but then, because maybe this was passed through a couple of other functions and you didn't even realize what the value, you're not seeing this explicitly necessarily. Maybe it came in through another variable. And so if I actually add this if statement and I throw the error, now when I run it, it actually throws the error properly, and it gives me the message. It tells me where it was that something went wrong, and it's a lot more helpful. Yeah. All right, I'm gonna cancel that out so that it won't run again. Okay, so that's the basic syntax. That's how you just intentionally throw an error where you think it could be useful to put it in the code. So again, here's the keywords, and throw and new, and then the error type. In this case, I decided to specifically throw a type error, not just a generic error, and then I gave it a message. And that is it for that one. Okay, so the last thing to talk about with exceptions is try, catch, and finally. This is a special syntax that gives you a chance to try an isolated block of code that you suspect could cause your program to fail. And you try it, and then if there's an error, you catch it. So it won't go ahead and throw the error first. It actually goes to the catch block instead. And you can do whatever you want inside of that to do something and maybe handle it a little differently. And so you also will notice that it has this E I've used here, and that can be anything. It can be error, it can be ERR. You could call it potato if you wanted to, really. But what it represents is the error object. So you're catching the error object, and now you have access to it because it gives it to you right there. And you could do things with it. And then the finally block is just a place where you can make sure that there's some additional code that will run before the entire sequence finishes. And anything that's in the finally block is going to run either way. So maybe you tried the code in the tried block and it didn't throw an error. So that skips the catch and it just goes to finally. But maybe you tried something, it got as far as it could. If it realized there was an error, and then you caught it and you did something in the catch block, but then it would still go to finally and it would run that code. So I have an example of this, and I'm trying to think if I think the first example I don't actually have on the slide, so we'll just go do it. Yeah, okay. So I've got a try, catch, and finally block here. I'm going to move this out. Okay, so here's my try block. I've got, console.log trying some code, and then I'm going to try to console log some data. Some data does not exist. And so, because I have it commented out. And so that's going to throw a reference error, right? Because it just can't find a reference, doesn't know what that variable is. So instead of going ahead and just throwing the error, which I could demonstrate like what would happen if you just do that. Yeah. So, it actually threw a syntax error because you have to have both try and catch. If you have one, you have to have the other. So my bad. But anyway, if you tried to just do this, then it would just throw the reference error. But instead, I'm going to catch it and I'm going to say, I want to do something different here. So the first thing that's going on here is I am demonstrating how I can just access the built-in object, what it already provides. And there's the name and there's the message. And then of course, there's the whole thing. So I will run that. I'm gonna log that out though. Okay, so we see the first line trying some code, and then we see, we don't see some data logged out because it doesn't exist. But we do see the code that's inside our catch block, and it says error name and then reference error message. Some data is not defined. And that's just what's built in. We didn't give it a custom message or anything. It's just built in. So we're just, and then of course you have the whole stack trace. So from the object. So this is kind of, this is what you have to work with if you aren't defining anything on your own. And then there's the text from the finally block that printed after it finished executing the catch. So here's, if I am not going to make use of that, I could create my own error instead. And I could just basically say, okay, if we arrived in the catch block, then we have an error. And chances are in this case, it's because I made this example, I know it's a reference error. So I'm going to throw a reference error. So I create the error and just say, I want to call this custom error. I want it to be a new reference error. And this is the message I want to give it. And I create it, and then I make use of it from there. And I console log a specially formatted statement that has these asterisks, and it gives you just the name on one line and just the message on the next line, because that's part of that error object that I created. And so now it's going to look totally different than just the stack trace with red text, right? So let's run it. Yeah. So we see trying some code, then it hit the error, and so it moved on, and now it only prints what I told it to. And that was the information that I created and formatted from my custom error that I created. And then of course the text from the finally block. So I can have all of this here. And let's say this time around, some data is available. What we expect to see is just the stuff from the try block and the stuff from the finally block. And it skips catch altogether because no error was thrown. It found what it was looking for. Okay, I'm going to do another example in a second. But okay, Mina?
How do we know that it is a reference error while creating the custom message?
You don't, and that's why I was saying, I'm just creating an example and I'm just showing you how you could do it. And so I know it's going to be a reference error because I set up the example. So I was just demonstrating how to do that. But the next example I do is actually going to deal with detecting error types so that you can tell. Okay, does anybody else have any questions before I do that? Okay, let's go back over to the slides then, and let's talk about this aspect of things, because it really is mostly useful when you can tell what's happening. And so you can determine an error type by using the instance of keyword. It works a little bit like type of, but instance of is used when you have an object that's based on a class. So you can use it to throw different error messages or run different code depending on which type is detected. Oops, I apologize. I went too far. Okay. So there's this example. I kind of have this very simplified. The one that I'm about to code for you is a little bit more advanced. So in this example, I try console logging B does not exist. And so then I say, okay, I'm going to try to catch, this error. If there's an error, and we've got this first block here, if E is an instance of a type error, then I'm going to say it's a type error. If it's an instance of a range error, I would say it's a range error. Otherwise, I just want to let it continue throwing it the way that it would have to begin with. So I just throw E. And then that's when we see, oh yeah, that's a reference error, right? So let's look at the code example of this. Let me comment this out. Okay. So I have a try and a catch here. I'm not bothering with the finally because we don't really need to. And I've got, an existing variable. I've got this C equals 5. And, B doesn't know if it exists or not. So we're going to start with it not existing for the sake of running through these examples. So we're going to try a few things, and it's going to execute this code line by line until it throws an error, if there is an error, and then it starts with the catch block. So right now we can see that probably what's going to happen is it's going to try to execute line 191, and it's not going to be able to because B doesn't exist. So let's run it. Yeah. So it tries, it catches that error there. And now I have E, and it says, we have a reference error, and now I'm logging out E.message. And so we see B is not defined. That's just the message part of the error object. And so I can say, okay, that's great. Let's fix that. Now we have B, it exists. And so now I'm going to run, and this time I hit a different error because it gets past line B. It's logged out A, it logged out B, but now it's hitting a type error because C dot to lowercase isn't a function because it went and checked the value of C, and C is a number, which is just like the one I did before with 3, right? So it's hit this one. So when it goes to the catch block, it's evaluating, what type of error is it? And in this case, it's an instance of a type error. So it executes these 2 lines of code that are inside this else if block. And that's what we see up here. We have a type error, C dot to lowercase is not a function. Let me finish this and then I'll answer you guys' questions. And then we get to C, and so I'm going to log that out and say, oh yeah, I shouldn't have done that. So we have a different type where I'm going to intentionally throw a range error only if the number is out of range. Okay. So it logs A, it logs B, and then we get down here and it says if C is less than or equal to 10, throw a range error and give it this message. But it doesn't just throw it here, it catches it first, and then it evaluates all of this. And in this case, it's not a reference error, it's not a type error. So it gets down here and we say now we can throw any other error that happens, and we just throw it. And so that's why you see it as if it had been thrown up here. But we actually did go through all of this, and we can prove that because we're seeing this line of code in the console. Kaylee?
This might be a stupid question, but so when we had B commented out and it's going through the loop, and then it stops at B, is there a way to get it to keep going on to C, or is it just definitely going to stop at that point, if that makes sense?
Yeah, that is, that's why you have the catch. Well, okay. If you wanted to do that, you would need to probably have them in 2 separate try catches.
Okay. Okay.
I did it this way only so that I could show it catching different types for the sake of running through this logic. But yeah, in a typical situation, you're probably only going to try one thing that might break, handle it, and then you might try something else that might break and then handle it.
Right, okay. One of the exercises, it had us do this try catch statement on an object, and it had a whole bunch of stuff in that object. And then I guess I wanted to go through the whole object to see if there's multiple errors, but I guess you would just do it one at a time then, right?
Potentially, it's totally, it depends on the situation. I've had
Okay.
some pretty complex try catches before where it was a case of retrieving data from an API, which is getting it from a database. And there's like all of these possible errors, which you guys are going to learn about in about 4 weeks about how to do this, how to fetch data. And you can have these different errors that come back. Probably everybody has gone to a web page at some point in their life and hit a 404 not found page, right? Because the page no longer exists. 404 is just one of many, many codes that can come back. And so there's like, you can have a lot of error handling. It's like, if it's this code, do this with it. If it's this code, do that with it. So sometimes you really do have to do it all at once. To make sure you're handling everything, because you're only actually going and requesting the data the one time.
Okay.
Yeah.
Thank you.
Mike?
I'm guessing your answer is going to be yeah, but for the try statement, I guess you could put like a function in there to see if the function itself returns something, right? It doesn't have to just be based on
anything.
Right?
It can be any code. Yeah. I mean, that's just it. If you have any sort of code at all that you think could potentially throw an error, depending on what data is, coming through or how it's being used, put it inside a try block, and then specify what needs to happen if there is an error. That's what the catch block is for. Yep. This can be very simple, but it can also be very complex. So you just kind of use it however you need to. Any other questions? Shweta?
So there was a example in the book with the try and the finally block. And in that example, they said that after finally is executed, anything below that is also like the code goes on.
Yes.
So I was wondering, if the code actually goes on, what is the actual use of using the finally block of code? Like, we can just do try catch and then like the code can keep going, if that makes sense.
Yeah, because sometimes you are, using these in functions that you're calling from somewhere else. And I'm trying to think, I'm having a hard time thinking of an example that is within the scope of what you guys know. It's a good question. I think that if you had a situation where you want the logic to flow in a way that you only are doing something as part of a certain sequence, then it can be helpful to put it in the finally block, because it makes it really clear that it's just part of that sequence. I know that's not probably very helpful, but yeah, I've had situations. I don't always use finally blocks. I've had a couple situations where I did. I guess because I didn't want the code right after it to get separated from it. Because
is it because anything on, like, I don't know, is it the scope thing, like anything in the try block can be accessed in the finally? Is that how it works? I'm sorry if I...
No, that's a good question, and I don't believe so. I believe these each have separate scopes. But you can imagine, like in this example up here, let me see how, okay, it's 6:30. All right, I'll do this real quick. You could imagine in this example that maybe, I've got some code down here that's after my try catch finally. And I, have, here, okay. Here is the code to print right after the try catch. And, I run this and it prints last, just like I expect it to. It does the try and all that. But then somebody else comes along a month later and they add some more code and they do, more code here, console log, more code. And now suddenly I've got something that was intended to be right after this that's not. I mean, there are probably other reasons, but right now that's the most practical reason I can think of is if you really do intend for it to be part of that sequence, you can group it with it by putting it up here instead. Oops.
Okay, yeah.
Yeah. So that way, no other code separates it out. Yeah. Sachita?
So can the finally block code actually be another function, or is it just?
It can be anything.
Okay.
Yeah, you can call a function, you can do anything. I'm using console logs because it's the easiest way to have something simple that shows you the sequence. You can kind of see the sequence of things printing out just to show you what order the code is executing in. But yeah, you can absolutely have anything.
Okay. Thank you.
Sure. Okay. With that, I'm going to send you guys off to studio. That's pretty much the whole of these topics for tonight. So you're going to talk about strategic debugging. Your TA is going to kind of lead you through a discussion. The bottom line is that you need tools in your tool belt for locating, diagnosing, and fixing errors in your code because they come up. And you have to be, learn how to be an independent thinker, how to do research and go, look into things and figure out what the heck's going on. And you'll get, with practice, you get better and better over time at diagnosing your own errors and not having to ask for help as much. So, it's a goal to work toward. And to do that, it's helpful to define a process that you kind of go through, and you want to be as methodical as possible because computers are logic-based, right? They only do what you tell them to do and the order in which you tell them to do it. And so if you can think like the computer and think through things methodically, you're going to be a lot more successful at finding those errors and finding them faster. So you guys can go into studio, you can talk about that. And I said solution on there. There is no solution. I'll take that off. But like I said, we'll come back. I will be here, let's say around 7:30 in case you guys get done earlier. Otherwise, come at 8 as normal. And I will, just answer questions and help you guys understand things that we've talked about up until today, and just try to be available to you guys. So Thursday, you've got your prep work on chapter 18 to do, and then we'll have lecture and studio and review on classes, which is a very important topic. And then next week, we start getting into web stuff, which I am super excited about, y'all. So we'll talk about the terminal, we'll talk about HTML. That's chapters 19 and 20. So you guys head on off to your studios, and I will see you back here in a while.